G'day again, question 13. The diagram shows triangle ABC with sides 6, 4 and 8. So it gives you a nice diagram. Always funny, they write not to scale. Now you'd think the Board of Studies, they've had this for 9 months, you'd think they'd be able to draw a diagram to scale. I think that's quite humorous, but anyway. Show that cos A equals 7 on 8. Okay, well that's pretty easy. You just use your cos rule. So cos A equals b squared plus c squared minus a squared over 2bc, and you just substitute in the numbers. So we're going to get 8 squared plus 6 squared minus 4 squared. So we're looking from this perspective, so that's your A, that's B, that's C, all over 2 multiplied by 8 times 6. Okay, punch that in your calculator, and wonder of wonders, you end up with, actually you can just punch in one at a time. If you punch in that and that, or punch it both at the same time, you'll end up with 7 on 8. Okay, which shows and that's an easy 1 mark. Second one, by finding the exact value of sine A, determine the exact value of the area of the triangle. So this bit's probably the hardest bit of the question, finding the exact value of sine A. So you've got to think, if you look at that, it's not going to work. What you've got to think of is a triangle. So you've got cos, so you think of your basic triangle. So if I look at a basic triangle, or a right angle triangle, and I'll make that theta. What is cos? Well, cos is adjacent over hypotenuse. So to find sine, I'm going to find this length here. So this length here is the square root of 8 squared minus 7 squared, which equals the square root of 64, take away 49, which is 15. So this length is root 15. So the exact value of sine A is going to be root 15 over 8. And you would need that diagram to get that answer, to get the mark. So for the 2 marks, that will be your first mark. Determine the exact value of the area. So the area of a triangle, you should know, is half AB sine C. So you've got this value. You don't have to do anything with it. It's right there. A and B are surrounding there and there. So that's your A and B. And this angle here, in terms of sine, is root 15 on 8. So you're just putting that in there. So that would equal a half multiplied by 6 multiplied by 8 multiplied by root 15 on 8. And you should be fast enough to know at this stage, I can cancel that and cancel that. A half of 6 is 3. So I'm going to end up with 3 root 15. And you're done. Back again, 13b. Find the domain and range for fx equals the square root of 9 minus x squared. So this should be fairly straightforward. Domain and range. So you're just finding the x and y values. Now, instead of having fx, I would tend to rewrite it as y equals root 9 minus x squared. Okay, because the less things you've got to look at, the better, and the easier it is for you to think. So this y, let's just think about this y. So what is y? Y is the range. So this range cannot be negative. You can't get a square root negative unless you're doing extension 2 when you're doing complex numbers. So this is just 2 unit. So this cannot be negative, and this whole thing cannot be negative. So y can't be negative. So our first move is to say, well, the range, you must have y greater than 0. Well, can y equal 0? Well, yeah, you could make this equal to 0. And what's the biggest thing y can be? Well, since this is negative, if we take this off, the biggest thing y can be is the square root of 9. What's the square root of 9? 3. So the biggest thing y can be is 3. So the range goes from 0 to 3. Okay, now let's look at x. So again, we've got to look inside here. Well, we can't make this negative. We can't make this number such that the whole thing becomes negative. Well, again, If we put 3 in there, 9 minus 3 squared is 0. If I put 4 in there, it becomes negative. So this number cannot get bigger than 3. So we know x, so this is our domain, cannot get bigger than 3. And if you look at the other end, when you do square root, x squared could be negative 3. A negative times a negative is a positive, so this could be minus 3. So your domain goes from minus 3 to 3, your range goes from 0 to 3. And you should be able to figure that out. You might not figure it out quickly, but if you sit there and think about it, so this is really a time constraint question. It's not difficult, but it will take time for you to think it through. So the faster you can look at things and put things in, the quicker you'll answer the question. So that's the first part. Second part, on a number plane, now they don't give you a number plane. I've actually drawn this. On a number plane, shade the region where the points x, y satisfy both of the inequalities, this one and this one. When you're drawing a region, forget about the greater than or equal to sign, just make it equals and find out the equation. So just look at that and say, well, what does that look like as a graph? And if you're unsure, this should be reasonably familiar, but one way to make it more familiar, let's square both sides. So if you square both sides, you get y squared equals 9 minus x squared, and let's move this x over here. X squared plus y squared equals 9, and if we, instead of writing that, we write 3 squared. That shape, or that form, should be very familiar. It's a circle, okay? So that form should be very familiar, and so should this, even though it may not be initially, but now you can get used to it. That's a circle, this is going to be a semicircle, and these are your limits. So x is going to go from minus 3 to 3, something like that, from there to there. Y is going to go from 0 to 3, and it's going to go like that, right? So you're going to get a semicircle. We're going to get a semicircle on that line, from there to there. Right, from minus 3 to 3 to 3. The other thing you want, you've got y greater than x, greater than or equal to x. What's y equals x? Well, you should know that one too. Y equals x. Well, it should be something you learn when you're learning your basic graphs. Your basic graphs to teach you y equals x is that line there. So that should be easy to just graph straight on there. Should use a ruler, but that's straight enough. Now you've got those two. Now how do you figure out what the region is? Well, very simply, just pick a point. And I would pick that point there. So that point there is 0, 1. And just put 0, 1 there and there. And if it's true, colour that in. If it's false, test another point. So you can just test points and see which one's true. Let's test that one, 0, 1. So we'll just put it into there, okay? So y, well that's y. 1 greater than or equal to square root of 9 minus 0. What's the square root of 9? 3. Is 3 bigger than 1? Yes, so that's true. Well, that's a good start. Let's try the next one. So y, so going to 1 is greater than or equal to 0. Well, is that true? Yes. Great, they're both true, so there's your answer. You just shade in that region, and you're done. G'day again. Question 13c. Consider the curve y equals x cubed minus x squared minus x plus 3. And then there's 3 bits. So we'll do one part at a time, find the stationary points and determine their nature. So this should be pretty straightforward. How do you find a stationary point? Well, differentiate, put it equal to 0. It's a pretty straightforward equation. So let's have a go. Differentiate that. You make it y dash. The 3 goes in front, that becomes a squared. So 3x squared. The 2 goes in front, that becomes a 1. Don't add an extra dash. So minus 2x. The minus x just becomes minus 1. The 3 disappears. So you've differentiated, now put it equal to 0. And we solve that. Now, it's fairly simple. You could use the quadratic formula, but it's fairly simple and you should be able to factorise that. There's only two numbers that you can use for 3x, and that's 3x and x. That's it, there's no other choices. And there's only two numbers you can use for minus 1. You can only use 1 and minus 1. So your only choice is to figure out which one of those is the minus and which one is the plus. So you want the multiplication of that and that to add up to minus 2x. So if you just put it in 1, if it doesn't work, it's obviously the other one. So let's put it in 1 there and a minus there, and let's see if it works. 1 times x is 1x. Minus 1 times 3x is minus 3x. That plus that is minus 2x, and yes, it works. So that's your combination. If it didn't work, you'd simply switch it around. There's no other choices to make it work. So that happens to work, great. So what's this? Well, 3x plus 1, the x must be minus a third. So we've got two answers of x equals minus 1/3. And what's your other choice over there? Well, x equals 1. Okay? So find the stationary points. All you're going to do is put each value, one at a time, back into there. Excuse me. Put the 1 in. So what do you get? 1. Take away 1 is nothing. Take away another 1 plus 3. Well, take away 1 plus 3 is 2. So for the x equals 1, your point is 1, 2. That's pretty simple. Put in the minus third, well, you're going to get minus 1 on 27, minus 1 on 9, plus 1/3, plus 3. And if you figure that out, so minus 1 on 27, minus 1 on 9, plus 1/3, plus 3. Figure that out. 1 1/3, take away, well, that's going to be 3 on 27. You could go, what do we got? Minus 1 on 27, minus 3 on 27, plus 9 on 27, plus 3. So you've got 3 and 9/27, take away 4. So you're going to end up with 3 and 5/27. So your other point is going to be minus 1/3, 3 and 5/27. So you could probably you're obviously quicker to do it on a calculator, but I didn't happen to have one. So there are your two stationary points. What are their nature? Well, how do you figure out the nature of a stationary point? You've differentiated once, which is a hint. You should differentiate again. So y double dash equals, just differentiate that. 2 goes in front and we get 6x minus 2. So that is the second differentiation. To find out the nature of each thing, you're going to put in the x value one at a time. So we're going to go y double dash of 1, to find out what that is. Put in 1 there. 6 times 1 is 6, take away 2 is 4. So that number is positive. So what I term that is, that's a happy face, because it's positive, therefore it's a minimum. It's a minimum because you're going to get a point down the bottom. So the nature of that point is a minimum. What's the nature of this point? Well, just put in the x value. So we're going to go y double dash of minus 1/3. So if we put in minus 1/3 there, we get 6 multiplied by minus 1/3 is minus 2, minus another 2, minus 2 minus 2 is minus 4. Well, that's negative, so therefore it's a sad face. If it's a sad face, it's going to be, therefore, it's a maximum, because it's going to have a point up the top. So the nature of this point is a maximum. And there it is. You've done part 1. I'll rub this out, we'll do part 2. Back again for part 2. So in part 1, what we figured out was that's y dash, that's y double dash, 1, 2 is a minimum, and minus 1/3, 5 and 27 is a maximum. Okay, so that's what we figured out in part 1. In part 2, you want to prove that there's a point of inflection at a point they give you, which is 1/3 70 on 27. So to prove it's a point of inflection, I wouldn't start with that. I would just start by finding the point of inflection. So how do you find a point of inflection? Well, all you do is you've got y double dash and you just put it equal to 0. So I would do it that way. So I would say y double dash equals 6x minus 2 equals 0, and then solve this to find our x value. 6x equals 2, x equals 2 divided by 6 is 1/3. So you can say, therefore, there's a point of inflection when x equals 1/3. You'd actually say that, therefore, point of inflection at x equals 1/3. Substitute that back into your original equation, and wonder of wonders, you will end up with 70 over 27. So sub back into y equals, and then rewrite the equation for the examiners so they know what you're putting it into. Or you can say sub back into original equation if you want to say it that way. Sub back into there, and you can actually, you don't even have to do it on your calculator, but you should. You'd sub it back into that equation, 1/3 cubed minus 1/3 squared minus 1/3 plus 1/3 equals, and it's going to equal 70 on 27. And so you've actually proved that that is, because you've started here, you haven't started with the point. So you can say, therefore, that point is the point of inflection. And you're done for part 2. Back again for part 3. So, just to recap, part 1, you found out this, this, and this. Part 2, you found out this. Now notice I've rewritten the inflection and the maximum so that you've got a number there. So you can actually see what position it is on the graph. And I would do that in the exam and find out what number that is, because otherwise you're thinking 70 on, where is that actually on the graph? So I would actually put a whole number there, so it's really clear to your head where you're mapping that point. You're given the majority of the points you need. The only other point you need, it says find the y-intercept. Well, how do you find the y-intercept? You put x equal to 0. So nothing, nothing, nothing. Guess what the y-intercept is? 3. So y-intercept equals 3. So now you have all the points to put on there and draw the graph. So you will just put a dot next to them. You can draw arrows to them. If you've drawn a small graph, draw arrows and say this is what the point is if you can't fit them underneath. So you've got an inflection at 1/3, pretty much 2.5, so 1/3 about there. So mark it with a fairly large dot, so that's your inflection. You've got a maximum minus 1/3, 3 and a bit, so minus 1/3, 3 and a bit, you got a maximum there. You got a minimum at 1, 2, so 1, 2, well, that one's pretty obvious. And you can see the curve, you can see how the curve's going, it's like that. So that's how your curve is going to look, and you should draw it with a proper line, like that. And then mark these points. Now, if you can't squeeze things underneath, then draw a little arrow to them, saying, well, that point there is, what have we got, minus 1/3, so that's our maximum. 3 on 5, 27, and mark under it max. And mark each point on there, each of those 4 points, very clearly as to what they are, because they're what they're looking for in the marking scheme, that you're marking each of those points like that very clearly, so you get 4 marks and you're done.